All right, let's look now at combinations, and we're going to solve combination problems that have distinguishable objects. Before we do, though, let's do a little bit of an intro here. So here's a scenario. Alan, Brent, Cole, and Dave are running a race. First place gets $50, second place gets $25, third gets $10. Let's list the possible outcomes of the race and determine the number of ways the prizes can be awarded. Well, if we're going to list the possible outcomes, let's start logically here. It could be Alan in first, followed by Brent, followed by Cole. First, second, third. In this situation, there would be no prize for Dave. Now that's if A comes first, then B, then C. And order is going to matter here because of the prizes. Well, we could also have A, then C, then B. B could have come first, followed by AC. Again, B could have come first, and then it was CA. Well, C could have come first, followed by AB, and C could have come first, followed by BA. And that's the number of possibilities where Dave doesn't finish in the top three, and the other three finish the race. Pause the video for a second and see if you can list the rest of the possible outcomes. So there's our possibilities, the number of possible ways. And if we count them up, we can see that we have 6 for each scenario. So we have 24 possible ways that this could occur. Now we could have also done that same calculation by doing 4P3. We have 4 people, and we have to pick 3 of them to determine the number of possibilities where order matters. That's just a permutation. Well, what if we considered this scenario? If the top 3 get the same prize, how many ways can it then be awarded? Now order doesn't matter. Now what matters is finishing in the top 3. But if we look at our first column, all of these would give us the top 3, A, B, C being top 3. Same thing for the second one, and the third one, and the fourth one. So again, if it doesn't matter whether you finish first, second, or third, just whether you finish in the top 3, now we can see from the circled ones, there are 4 ways for this to occur. Well, what have we done to our original permutation? Well, we have taken it and we have divided it by 6. Now that might seem like a strange number. Where does that come from? But remember, 6 is the same as 3 factorial. And the 3 comes from our first, our second, and our third. The 3 people that we want to pick. So if order doesn't matter, we're just going to take our permutation and divide by the number that we are picking. That's going to allow us to write a formula for a combination. And what a combination is a set of elements in which the order is not important. We still use n and r. We have n objects taken r at a time. And all a combination is NCR. Again, we might see it in this notation, n comma r. But we just take a permutation and divide it by the r, the number we have. In this case, we're going to say chose for C. Well, NPR divided by R factorial just becomes this equation. N factorial over N minus R factorial, and again, N and R are always greater than 0. So if we want to find a combination, it's very similar to a permutation. We just have to consider, does order matter? So let's look at this situation. A hockey team consists of 18 players. There are 25 that are available that we are going to choose from. How many ways can this occur? Well, the first thing we have to determine here is order. And when we're being chosen for a team in this case, the order does not matter. We don't care if we're chosen first or 18th. We just want to be chosen to be part of that team. So the order doesn't matter. If that's the case, we know it's NCR that we're going to use for this calculation. And NCR, remember the new equation is n factorial over n minus r factorial, same as the permutation. We just add another r factorial. In this case, n is the number of people we have to choose from, and r is the number of positions. So we just put that into the equation, and we would get 25 factorial over 25 minus 18 factorial times 18 factorial, which is really just 25 factorial over 7 factorial times 18 factorial. So if we fire that in the calculator, you get 480,700 different ways that this can occur. A number of ways that are possible. Well, just like NPR, NCR also has a button on the calculator, and we're going to use that button for the next question. How many committees of 5 teachers can be selected from 7 male teachers and 5 female teachers if the committee must contain 2 female teachers? Now we have a restriction. We have to choose a certain number of female teachers, and by default, a certain number of male teachers. Well, let's start with our scenario. What we're trying to do is we need 2 female teachers, and of course, that means we're going to have 3 male teachers. And if we find the number of female and then the number of male, we can use the fundamental counting principle and multiply them together. Well, let's first choose our female teachers then. From the 5 female teachers, we choose 2 of them. We'll figure out whatever that number is, and then multiply it by our male teachers. Of the 7, we're going to choose 3. Now this time, use your NCR button on your calculator to do the calculation. 5C2, if you use your NCR button, 5C2 will give us 10, and 7C3 will give us 35. And then, fundamental counting principle, multiply those 2 values together, we get 350 ways that could occur. The important thing about a combination is order doesn't matter. So we use NCR instead of NPR. And we're going to do a number of questions like this and apply this in class.